The third type of combinations of cell. This is known as mixed grouping of cell. So in mixed grouping of cells, we have both a series and a parallel combination. So as you can see in this figure, we have n identical cells connected in series, and each such cells, right, or all such n cells now, all such identical n number of cells now, they are connected in parallel. So that means in the first row I have n number of cells connected in series. In the second row also I'm having n number of cells connected in series. In the third row, in the fourth row, and then up to how many rows? Let's say m rows. So all these cells are connected in series and as well as in parallel. Okay, and these are the common points A and B, and this common point A and B, now it is connected to the external resistance capital R. Fine. Now let us find out what is the total EMF of this combination, what is the total internal resistance of the combination, and what is the total resistance of the circuit, and also we shall find out what is the current. Okay, so because looking at the first row, how many cells are there? N cells. So therefore, if each cell is having EMF E and internal resistance R, so the total EMF of the first row is how much? N times E. So if the EMF of the first row is NE, similarly the EMF of this will be NE, EMF of this will be NE, and the EMF between the 2 points A and B also will be NE. So which means the total EMF of the combination is NE. Alright, okay. Now looking at the internal resistance, the total resistance in the first row, total resistance in first row, it will be small n times R, where R is the resistance of each cell. Now this NR, which is the total resistance in each row, now these NR, they are connected in parallel. So therefore the total resistance of the combination now become, so total resistance, let me denote by R equivalent, of the combination will be how much? 1 upon R equivalent is equals to 1 upon NR, which is the total resistance in the first row, plus 1 upon NR, resistance in the second row, and so on up to M times. Or I can say 1 upon R equivalent is equals to M times 1 upon NR, or my R equivalent is equals to NR upon M. This is my equivalent resistance. Next, what is the total resistance of the circuit? Total resistance of the circuit is equals to capital R plus R equivalent. Okay, so now I have found everything: total EMF, total internal resistance, and total resistance of the circuit. So therefore I will find out current passing through the external resistance R. So we always know that this current is usually given as total EMF upon total resistance of the circuit. So my total EMF is NE, total resistance is R plus R equivalent, or NE upon R plus, instead of R equivalent I can write NR upon M. Or sorry, I have to again, I hope you have a notes with you. There is no problem, right? You can look through the notes also about the calculation part. Okay, so now simplifying this, you'll get I is equals to NE upon, find out the LCM here, you will get MR plus NR, and this M, right, which is here, now if you take it up, then it moves to this position. Alright, okay, so this is my equation, let's say equation 1. Okay, so again, just like in case of series and parallel combination, I want to know what is the condition to get a maximum current to the external resistance. So looking at this equation 1, this current I will be maximum if this denominator is minimum. That means I is maximum if MR plus NR is minimum. So MR plus NR is minimum. What does it mean? It means like this. Because this MR plus NR, I can write it as root MR square plus square root NR square. I hope this is fine, because when you cancel the square with the root, you'll get back same thing. Or I can also say this as root MR square plus root NR square. Now I will add and subtract with this. Fine, because adding and subtracting by the same quantity, it does not change the equation, so you get back the same thing. Or MR plus NR is equals to, now considering this, this and this, I will write MR, okay, or I can say root MR square, okay, plus this root NR. Okay, to shorten the step, I will write this is equals to root MR minus root NR whole thing square. So when you write this, you'll get MR square NR square minus 2 MR NR. So outside you'll have just 2 square root MR root NR. Okay, all right. Okay, so let me come back to this equation 1. I told you that in order to get the maximum current, this MR plus NR should be minimum, which means, because I have simplified MR and R as this much, so when MR plus NR is minimum, it means this whole thing should be minimum. So for this whole thing to be minimum, that means you should get a small number. But you know this, because of the presence of the square, so this quantity cannot be negative. That means it cannot be minimum, right? Are you getting my point? When the, you know, because it is a perfect square, so this cannot be negative. So therefore, it is this quantity, if this cannot be negative, right? This cannot be negative because it is a perfect square. So I will write this MR plus NR will be minimum only if, right? Only if MR minus root NR is equals to 0. Because the least value of this is 0. The least value of the square is 0. You cannot have a negative, when you take the square. So in order to make this minimum, this quantity, right, should be minimum. And if this is minimum, that means this should be 0. Because square cannot be negative, so we cannot take the negative value, but the least value of this is 0. Or I can say MR under the root is equals to NR, or MR is equals to NR, or capital R is equals to NR by M. So when you go back, right, if you look at your notes, that for the equations I have written before, this capital R, I mean this NR upon M, this is the total resistance, the total internal resistance of the combination. So therefore, In a mixed grouping of cell, in order to have a maximum current in the circuit, the external resistance capital R should be equal to the total resistance, to the total internal resistance of the combination. So this is all about the mixed grouping of cell. Thank you very much.